welcome to another mathematics presentation. So in this presentation, I want us to look at mathematics paper 2 for 2024. So this is the paper that was written by GCE candidates grade 12. So we are going to look at question 1B, and this is our question 1B. The question reads, the Venn diagram shows the number of elements of set P, Q, and R. So this is the Venn diagram consisting of three sets, set Q, P, and R. So, question, find Roman numeral 1, find the value of x such that NP is equal to 18. So, when you see NA and P in brackets, P is the name of the set, NE is the number of elements that are in set P, which is equal to 18. So, this is giving us 2 marks. So, in order for us to answer this question, we are going to do this. So we are answering for Roman numeral 1. So they have told us that n number of elements in set P is equal to what? 18. So we come back to our Venn diagram. This is our set P right here. So inside this set P, there is another set, which is set R. So set R is a subset of set P. Okay? So set P, it has these elements x, 2x plus 1, and x plus 1. So this x plus 1 is inside set R because set R is a subset of set P. So the elements which are here, they are also found in set P. That's why this R is a subset of set P. So here, how can we find the value of x? So to find the value of x, we are going to add all the elements that are in this set P. Okay? So we have x, then plus x plus 1, plus 2x plus 1, then is equal to 18, because they have told us that the total number of elements of set P is 18. So we are going to have x plus 1. So this is the x plus 1 plus 2x plus 1, this one. Then we equate this to 18. So this is our first part. Then from here, what are we going to do? We can say x plus 1 plus 2x then plus 1 is equal to 18. So here I've just opened these brackets by multiplying with a positive 1, which is outside the brackets. So we just add now the like terms, x plus 2x. So when we add these three, we add x plus 2x. This will give us 4x, because this is 2x, 3x, 4x. So here we are going to have 4x, then plus, so positive 1 plus 1. So this will give us a 2, which will be equated to 18. So from here, we can group the like terms. So positive 2 can go to the right-hand side. We are going to have 4x is equal to 18 minus a 2. It was a positive, it becomes a negative. So here we can say 4x is equal to 18 take away 2. This will give us 16. So we want to find the value of x, of which we are going to divide both sides with the coefficient of x, which is a 4. Even here we divide by 4. So here we can now cancel this 4 and this 4 out. Then 4 here, 1. 4 into 16, it's a 4. So on the left hand side, you have just remained with x. So therefore, x is equal to, so 1 into 4, it's a 4. So x is equal to what? To 4. So this is the value of x. Now, we can now try to put it back. We substitute where there is x, we put the value of x that we have found, so that we can see the numbers clearly. So here, in set R, we add x plus 1. So x is a 4, 4 plus 1. This will give us a what? A 5. Meaning that in set R, we are going to have a 5. Then here there was x. So here it will be just a 4. Then here we had a 12. Okay. Then here we have 2x plus 1. So 2, where there is x, we substitute with a 4. Then plus 1. This will give us 2 times 4, it's 8 plus 1. This will give us 9. So here we are going to have a 9. So I hope this is clear. So we can now use this Venn diagram to answer the rest of the questions. So let's look at our question, Roman numeral 2. So this is our Roman numeral 2. Find the number of elements of R complement. So they want us to find the number of elements. Okay, so this is Roman numeral 2. Number of elements of R complement. So how can we find the number of elements of set R complement? So we understand that complement means the number of elements that are in set R should not be part of the solution set. So if we remove this set R, we will remain with which numbers? 12, 4, and 9. So here we are going to say number of elements of set R is equal to, so I've said you remain with a what? A 12 plus a 4 plus a 9. Okay, and this will give us a what? This is the number of elements that are in set R complement. Okay, so sorry for that, the complement was outside right here. So we have now answered our Roman numeral 2. We now proceed to our Roman numeral 3. So let's look at the question for Roman numeral 3. So this is our question. Find the number of elements of set R union set Q. Okay, so they want us to find the number of elements of set R union set what? Q. So this is what we have. Set R union set Q. Okay, so union means we combine the elements that are in R with the elements that are in Q. So set Q is this one, which is having 12, 4. Okay, then set R is having what? A 5. So when we combine the number of elements that are in R union Q, so we combine the elements in R and Q. So set Q is this one, 4, 12 and 4. Set R is a 5. So this will say number of elements if of set R union Q is equal to, so you say 12 plus 4 plus 5. Okay, so here we are going to have number of elements of R union Q is equal to, so when we add 12 plus 4, this will give us 16. 16 plus 5, this will give us 21. So this is the number of elements of R union Q. So I hope that you are following. We now come to our Roman numeral 4. So this is our Roman numeral 3. So let's look at the question. So this is our question. Find number of elements of P intersection Q in brackets complement. So we look at our question. So they want us to, we are now on Roman numeral 4. Number of elements of P intersection Q in brackets complement. Okay, so how can we find the number of elements of P intersection Q in brackets complement? So P intersection Q, P intersection Q, we look at our diagram here. P intersection Q, it's this part right here. This is the part. Okay, P intersection Q. Now complement, so they are saying this one should not be part of the solution set. Okay, this number 4 should not be included in our solution set. So here we are going to say, number of elements of P intersection Q complement equal to, so if we remove 4, okay, which is intersecting with P intersection Q, we remove this 4 in the number of elements, we are going to remain with what? 12, 5, and 9. So we are going to say 12 plus 5 plus 9. So we can now say, therefore, number of elements of P intersection Q complement equal to, so 12 plus 5 to give us 17, 17 plus 9 this will give us 26. So this is the number of elements of P intersection Q complement. So I hope it's clear. We've now come to the end of our session. Thank you so much, everybody, for having time to view this content. This has been your presenter, Mr. Mlenga. Bye-bye.